North Korea reveals suicide drone performance test and mentioned plans to produce more of these suicide drones. This type of suicide drone is also inexpensive to produce and is not easily detected by radars, making it suitable for attacking various targets like tanks and armored vehicles, and is currently being used. It's also attracting global attention, similar to indiscriminate drone attacks worldwide. Last April, Iran's drone attack on Israel stirred up controversy. The threat from unidentified objects falling from the sky. Here in our country, we also face threats from unidentified flying objects. These include potential attacks using drones or unmanned aerial vehicles. This is a situation that cannot be overlooked. If we were to attack these drones or UAVs with missiles, it would lead to excessive missile use and high costs. What if, like in the movies, we could destroy drones with laser beams? Laser, Shaksher, light, amplified by stimulated emission of radiation, might be relatively easy to shoot them down. Scenes straight out of What If such technology could be seen in our defense systems, silently and invisibly targeting and destroying the enemy with a new weapon system. It's said to be the first deployment of its kind in our country. Today's topic on TechNote Laser, anti-aircraft weapons. Once fired, there's no escaping. The drone-catching laser anti-aircraft weapon. When we think of typical weapons, these weapons share a common feature. They move directly to neutralize the enemy, the kinetic energy of projectiles. Regarding explosions, they add chemical energy to neutralize targets. But laser anti-aircraft weapons differ significantly from conventional weapons due to the unique properties of lasers. Laser weapons operate on light.
They illuminate targets with light, shooting beams to neutralize them. This is their main feature. Thus, as long as there is power available, they can fire continuously. Increased logistical support, reduced firing costs, because all they to power the technology is electricity for the laser. This makes them effective against mass-produced strike weapons like small drones, making them cost-efficient and laser weapons. Target with light, firing at the speed of light. What this means is the moment you target something, it has already been hit by the laser. As soon as it's targeted, it gets hit at the speed of light, making evasion practically impossible. Another feature of light is it travels in a straight line. Unlike bullets or shells that follow a curved path, its straight trajectory makes it extremely accurate in hitting targets. This laser weapon targets and downs enemies since the late 1990s. Provided by HANHWA, focused through the Agency for Defense Development, has been developing it in partnership with HANHWA Aerospace and, in 2019, source. Provided by Defense Acquisition Program Administration. The Defense Acquisition Program Administration initiated Block 1 of the Korean Star Wars project, and this year these laser weapons are now entering full-scale production and are scheduled to be the first in the world to be officially deployed in combat. Of course, there are countries like the USA with more advanced laser weapon technologies than ours, but our country is the first to officially deploy these laser weapons in actual combat, developed to shoot down small unmanned aerial vehicles and drones. The Block-I laser anti-aircraft weapon follows the trajectory of targets identified by radar using fiber optics to amplify the light source laser and directly targets them to neutralize its anew. Concept weapon system shooting lasers at the targets heats them to several hundred to over 1,000 degrees Celsius, destroying components like the engines of enemy drones.
The output of Block-I is 20 kilowatts. It can target and neutralize within 10 to 20 seconds, and it's effective at a range of 2 to 3 kilometers, but its accuracy is such that it can hit a spot within a few centimeters from a distance of about 1 kilometer. So comparing it to a nickel-sized coin, it can differentiate between the top and bottom to the extent that it can accurately strike either side, and it has enough power to penetrate such a coin. That's the level of its power. Additionally, the cost per shot is approximately $2. Compared to kinetic energy weapons, it's significantly cheaper. However, the initial cost of the laser weapon itself is high, leading to debates about its real cost-effectiveness. There's ongoing debate about its value for money. Despite the high costs for research, development, and installation of laser weapon systems, these expenses are considerable, similar to other systems requiring missile launch and tracking capabilities. The installation costs are also substantial, and each launch can be quite expensive, not to be underestimated. Therefore, with laser weapons once installed, they eliminate the need to produce expensive missiles. The more they are used, the more cost-effective they become. Last April, in the test evaluation, 1 shot, 1 kill within 3 kilometers. Drone-catching laser targeted at 30 unmanned aerial vehicles beyond 3 kilometers. The laser was fired 30 times, hitting all 30 targets, achieving a 100% hit rate. The evaluation results showed that firing the laser 30 times at unmanned aerial vehicles 3 kilometers away resulted in hitting all 30, recording a 100% hit rate. Currently, the output is low, source, provided by HANHWA, so it's primarily used against small unmanned aerial vehicles and drones, but with future improvements in output, it's expected to handle larger targets like aircraft or ballistic missiles. That's the expectation for the future. So how does a laser anti-aircraft weapon work? Let's first look at what LASER stands for. Laser light amplification by stimulated emission of radiation. To simplify the structure of a laser, at the center is the laser medium, that is, the material through which the light passes. This could be a solid, liquid, or gas. At both ends, there are 2 parallel mirrors. One mirror fully reflects the light. The other, a partial mirror, allows only amplified light to pass through. When light is directed into the laser medium, it emanates from the medium and gets trapped between the 2 mirrors. The trapped light then amplifies as it repeatedly bounces between the mirrors. Once the amplification exceeds a certain level, it escapes through the partial mirror. This is exactly what a laser is. This amplified light, known as a laser, has strong directivity, meaning it does not spread far as it travels. And because it doesn't spread, the intensity of the light remains largely unchanged. However, a standard laser can't burn a drone. The reason it can be used as a weapon based on light is if you've ever used a magnifying glass to burn paper. When you were younger, you might relate. When light is focused to a single point, the energy concentrates at that spot, which is why it can burn paper. When using lasers as weapons, a mirror that focuses the light like a magnifying glass is required. Mirror like a magnifying glass, which is a convex lens. There's a mirror that focuses the light, but this one is a concave mirror. Concave mirror. Convex lens. Using a concave mirror as a beam focuser, it concentrates an incredibly powerful laser beam onto a single point on the target. And to track moving targets, it works in conjunction with sophisticated tracking algorithms. Tracking system consisting of high-speed precision steering mirrors aiming system. This allows the laser beam to continuously target a specific point on a moving target. The downside is, it requires a relatively long time to focus. Actually, firing missiles to hit targets also requires time to reach those targets. So having some exposure time, might be acceptable. That's just my personal opinion. But since you need to continuously track the target, shorter exposure times would be preferable. However, this issue can be resolved by increasing the power output. From what is known, more than 100 kilowatts is required to down missiles, and with outputs below 50 kilowatts, drones need to be targeted for at least 3 to 4 seconds. With outputs below 10 kilowatts, it is possible to neutralize stationary ground explosives or deactivate unexploded ordnance. So enhancing the power output is key. Techniques to increase laser output include wavelength-controlled beam combining and coherent beam combining. Wavelength-controlled beam combining involves breaking down light, wavelength-controlled beam combining method, into its component spectral colors, red, orange, yellow, green, blue, indigo, and violet, using a prism in reverse to how it typically disperses light. This method recombines these wavelengths into a single beam, diffraction, grating, multi-wavelength light source, fiber array, transmission mirror.
To enhance the laser output, coherent beam combining involves adjusting each laser beam to ensure they are all in the same phase, so that the phase-aligned beams cause interference, creating a single high-power beam. Another technique, instead of just increasing laser output, there's a method to intensify the focus of the light by enlarging the size of the mirror. Remember the focuser I mentioned earlier? Enlarging this focuser while keeping the laser output the same is a way to increase the intensity of the laser. Though it sounds like technology from a sci-fi movie, it can actually neutralize enemies at the speed of light and enables precise strikes and sustained engagement. Laser weapons are thus viewed as the next generation of weaponry, particularly in modern warfare where they are used to destroy drones. Such laser weapons are considered efficient tools. However, before laser weapons are deployed in combat, there are still significant challenges to overcome. Laser weapons are susceptible to weather conditions like rain or fog, which presents a disadvantage. Under typical conditions of fog or rain, their effectiveness may be reduced, but they remain operational. Given that destroying drones or artillery shells requires high output, large beam focusers and powerful lasers are needed, thus requiring extensive equipment. High output also means a lot of power is needed, which can cause overheating. Cooling systems are essential to mitigate this and must be integrated into the large-scale setup. Now that operational deployment has just been completed, technologies to improve these systems are expected to continue developing. This year, South Korea will complete the deployment of Block E, and the next phase, Block 2, is expected to be developed before 2030 as a 30-kilowatt mobile unit. Following 2030, development will begin on the 100-kilowatt Block 3. Development of the laser anti-aircraft weapon Block 3 is scheduled to start after 2030. Capable of intercepting not just mid-range drones but also missiles, Block 3 will be capable of intercepting both mid-range drones and missiles, significantly enhancing its performance. This laser weapon, designed to shoot down drones and unmanned aerial vehicles, is a revolutionary technology that could alter the dynamics of future warfare. Such technological advancements not only bolster military power, but also significantly enhance the overall stability of defense capabilities, providing strong support for defense strategies. Moving forward as planned, if the technological developments are successful, they could intercept even aircraft and ballistic missiles, becoming an essential weapon. Laser anti-aircraft weapons that can transcend physical limits. This laser weapon could be a game-changer in future warfare. No longer just a scene from a movie, it's becoming a reality. South Korea is the first in the world to formally integrate laser weapons into its armed forces. From an economic standpoint, further developing the operational concepts and systems for these laser anti-aircraft weapons could also position us to lead the defense export market, which is something to look forward to.
North Korea is developing a suicide drone weapon.
하얀색 무인기들을 살펴봅니다. 하나는 삼각형 모양이고
Kim
다른
Jong-un is
하나는
urging to
X자형
develop and
날개가
deploy
달렸습니다.
as soon as possible.
북한은 이
Suicide
무인기들이
drone
자폭형이라며
unveiled for the
가상
first
표적을
time.
타격하는 성능 시험 장면을
General
처음
Secretary Kim
공개했습니다.
Jong-un, who visited the Agency for Defense Development's Drone Research Center, examines a white drone. One is triangular in shape, and the other has a letter-shaped wing.
X자형 날개가 달린
North Korea
무인기가
has
우리
revealed for the
KT-전차
first time
모형
a
표적을
performance
수직으로
test
타격하는
scene of
장면도
striking a
공개했습니다.
virtual target,
자폭형
claiming
무인기로
that these
장갑이
weapons are
상대적으로 약한
suicide type.
탱크 상부를
The various
직접
weapons were fired
공격함으로써
along a set
상당한
path,
위협이
and
될 수
all of them
있음을 과시한
accurately
겁니다.
identify and
북한
destroy the
무인기는
designated enemy.
이스라엘과 러시아
A scene was
무인기를
also
모방한
revealed of
것으로
a
추정되지만
suicide-type
자체
drone
개발
vertically
가능성도
striking a
있습니다.
model South Korean's main K-2 tank target. The drone showed that it could pose a significant threat by directly attacking the relatively weak armor of the upper part of the tank. The North Korean drone is believed to be a copy of an Israeli or Russian drone, but it is also possible that it was developed by the North. It is also possible that Russia entrusted it to North Korea for mass production, and it cannot be ruled out that the drones themselves are not completely cutting-edge high-tech drones, so it cannot be ruled out that North Korea developed them by itself. North Korea also said that they need to develop their own analysis, so we are going to do more analysis. Kim Jong-un encouraged them to conduct more intensive combat application tests of weapons and deploy them to the units as soon as possible. In July of last year, North Korea unveiled a strategic unmanned reconnaissance drone and an attack drone during a military parade. There is analysis that North Korea, which has a relatively weak air force, is focusing on developing unmanned weapons that are suitable for modern warfare and can be developed at a low cost.
North Korea's drone that looked like a new. When did it get this big? It's official. The large drone, unveiled at this North Korean military parade, looks similar to the advanced U.S. drones. The drone unveiled at the parade on the 27th resembles the U.S. Global Hawk or Reaper. It is not known how well it performs, but based on its appearance, it seems that these drones could play a threatening role. The U.S. military's Global Hawk is the world's best-performing long-range strategic UAV and has been used in actual combat in Iraq, Afghanistan, and other areas. It is possible that North Korea could use the drone to monitor South Korean military units or serve as a role in the metropolitan area. It is possible that North Korea has developed a large weapon that can pose a real threat beyond the small UAV that infiltrated the metropolitan area last year. Introduction of strategic UAVs, Bilsaogi. North Korean drones that first appeared at the parade. Kim Jong-un, thumbs up. The parade pre-ceremony began with a flight of a purpose-built attack drone over Pyongyang. After the first appearance of the weapons exhibition reported yesterday, which was modeled after an advanced U.S. drone, the actual flight was held. Korean news agency SBS.
대형 장비 10병의 마지막은 최신형 대륙간 탄도미사일 화성 18형과 화성 17형이 맡았습니다.
미 전략 핵 잠수함이 아주 위험한 수역에 들어왔다는 것을 엄정히 경고한 상태입니다. 이제는 조선 반도에서 누가 언제 어떻게 핵전쟁을 일으키는가 하는 것이 문제로 되었습니다.
김정은 체제에서 개발된 신무기들로만 역동적인 열병식을 벌일 수 있을 정도로 최근 북한의 군사력은 강화됐고 중국과 러시아의 고위 대표단을 부른 것도 이런 자신감에서 비롯됐다는 분석입니다. SBS 김태훈입니다.